that we go in for in Scotland that much, because these satellites are very large. They are launched very high above the equator, 36,000 kilometers up in geostationary or geosynchronous orbits, depends on where they are, but they're really high up, really big investment. And there's a couple of these sort of global systems like the GPS itself, or GLONASS, the Russian version, or indeed the Galileo program from the European Union, and that's kind of really dominating that kind of field. And there's no point in building small satellites to compete with that. It's a similar story in telecommunications. Telecommunication is still the best business in space. So if you're going to the space industry to make some money, don't do GPS. Only big countries can afford to do that. You also might not want to be doing the Earth observation side of things, even though it's exciting, which is something that I'll try to convince you of today. It is not yet very lucrative. The big thing is satellite communications. Of course, we all know the story of B-Sky B, one of the first satellite TV companies in the world, and still one of the most successful ones. Big sort of British space success story, really. But also in terms of telecommunications, in terms of phone over satellite, the UK is world leader in that technology, particularly in terms of secure communications. In fact, the UK is home to something called Skynet, which is the most capable secure communications satellite system probably anywhere in the world, and that's shared with well, obviously the military uses it and the Navy, as well as this is shared with some of our NATO allies. But again, that's quite expensive, big business. There are now new things coming online, like you might have heard of something, and these days this is a bit of a dirty word, something called Starlink constellation, which is a proposal for several thousands of small satellites, similar to the ones that are being built in Scotland, to create effectively a global network of satellite communication in between these small satellites flying low in the low Earth orbit. And of course, that has lots of problems. And if you want to, we can have lots of kind of discussion about it. None of these problems are as big as the one that astronomers face, of course, which is you're now not seeing that much of the dark objects in the night skies. You're mainly seeing these flash pings of light as they're coming across your field of view. So that's a different issue. But we're going to skip these two a little bit today, because we'll focus on the way the Earth observation is changing the way we see the world. When we talk about satellite data, I mean, the other two are effectively also satellite data, but when we really talk about satellite data, we mainly mean imagery from space. And of course, some of that imagery is in the optical spectrum, and some of that imagery is not in the optical spectrum, like radar imagery from space as well. But basically, it is mainly different kinds of images of the Earth's surface from satellites flying above. Images like this, and this image actually has been downloaded from the Dundee satellite receiving station from one of American meteorological satellites. And it's a very, very peculiar image, because it kind of never happens really that the whole of the UK has clear skies like it has at this particular photo. I mean, not the whole of the UK, actually. Northern Ireland, to be fair, looks like it's raining down a bit on Northern Ireland, but everything else is fine. Everything else, the rest of the UK is completely bathing in sunshine. So there you have, this is basically what a satellite image effectively looks like. But of course, this is a relatively simple image. It's also from relatively high up. What you really want to do is to have more detailed images and to engage in a little bit more detailed processing. And this is a very good example, for instance, what that actually means. So satellite images of a bit of Western Africa, for instance, can be analyzed using sort of color pixeling in order to map out flood risks and drought risks and fire risks in a particular area. So effectively what happens here is satellite data has been downloaded, the raw imagery has then been analyzed using various sort of color parameters that correspond to a particular state of the matter on the ground that reflected the light. Of course, with satellite imagery, most of the satellite imagery, save for radar, so from synthetic aperture radar, everything else works much like your camera works effectively. It's not actually it's just taking images of the reflected light from the surface. So it is just detecting what the surface is the light the surface is reflecting. But you can do quite clever things. You can effectively identify shapes. So you can map out things like tree canopy, or even sometimes sort of sort of geographical features, geological features, and in some cases even sort of smaller things than trees, like particular kinds of shrubberies and things like that. So that's just basically on the virtue of resolution and being able to spot the shape on the ground. And then also by being able to analyze the color very closely, you can figure things out. There are sort of second order parameters like water moisture. How much water is there in a particular sort of piece of land? And you process that, so you pixelate it out, you analyze this pixel against each other and against some kind of model, some kind of reference values, and you can produce images like the one that's in the top right corner, which is effectively some kind of a map of the same area, where they've actually looked for sort of flood risks and social vulnerability due to other parameters. And then the interesting last bit is that this is just a map, right? A map doesn't really. I mean, I've promised you that satellite data is changing our worldview, is changing how we actually behave and live. And the bit here that is kind of missing is that, like, so what does this flood map actually mean? Well, it means that new policies can be introduced, new solutions can be introduced for community development that can, of course, combat let's say this flood risk or this social vulnerability. And this is all framing part of something called the sustainable development. And there's this this big program, international program of sustainable development goals, which is trying to for the first time probably in human history, align the technological and social development across the globe towards achieving effectively a more equitable and more sustainable planet. And you can kind of see there's 17 of these goals. Some of them are quite kind of ambitious, and some of them it's a bit sad that we still need to deal with in the 21st century, like no poverty, zero hunger, and good health and well-being outcomes. And of course there's some that are quite social. So there's not everything here is an environmental problem. Things like gender equality or consumption and production, these things are not necessarily based on natural environment. It's also just the way society works. But there's clearly some here that are specifically about protecting the natural environment. Things like 13, 14, 15, tackling climate change, and then sort of managing life below water and on land. And in many ways, these always kind of impact other things. So if you're not actually able to manage, let's say, fish stocks, or understand the way the sustainable ocean management works, then quite quickly you'll end up with troubles on coastal states where they want to fish, because, like, in fact, we know this is a very sad, tragic story, but there has been this extraordinarily civil war in Somalia. It was effectively based on the fact that the local fish stocks dropped to the point it was not sustainable for the people to survive on fishing. And based on that, whole host of sort of social tensions between different community groups started. Piracy started to spiral, it started to come up and spiral out of control. And in the end, various navies, including British Navy, actually deployed to the Gulf of Aden and along Somalian coast to try and ward off attacks from pirates. But of course, the original problem wasn't necessarily just piracy. The original problem was poor management of natural environment. So the idea behind Sustainable Development Goals is that we would be better organized as humans in a slightly nicer society, but also that we'll be better managing our environment. There are particular ones, however, that require, if you think about sort of things like climate change and management, land management, if you want to do this on global scale, you really need to have global data. And one of the best sources of global data for these problems is actually satellites. In fact, the SDGs have 162 indicators, which are divided in these 17 different goals, and so you can measure just how well our different sort of environmental management protocols, for instance, implemented. And I've just listed a couple where you can actually use satellite data directly or in combination with some other ground-based data in order to mark progress towards sustainable development. And there's a very interesting project just right in the example that I've put on the side of this slide is quite interesting. Effectively, it's satellite images of rooftops. It's counting rooftops, and it's not, of course, manually counting rooftops. It's using a clever computer algorithm who's able to process satellite data to identify rooftops. And by doing so, you can actually calculate, population density, and in particular, population density in very, very kind of difficult places to measure, like in favelas and slums around the world. And it's an interesting way because actually, if you overlay the imagery of rooftops with the count of cars, which is actually what the bottom pictures are, so it's counting how many cars there are on the street, that is actually an indicator for poverty. Because if you have loads of rooftops and no cars, that basically obviously means there's lots of people living there, but they're of very, very low social status. And on the other hand, you often have places where there's very few rooftops, very few houses, but quite a lot of cars. Nice people who can afford to have multiple cars, even though they have one house. So there's ways, like, this is kind of a very intuitive, very simple example, but there's actually ways in which you can measure not only natural environment, but also the societal factors that go along with it using satellite data. And this is where it becomes very, very interesting. In fact, I was involved in something called the Frontier Development Lab, or the European version of the Frontier Development Lab, which is a European Space Agency funded sort of hackathon. If you're familiar with hackathons, it's sort of alternative ways of producing new technologies or new solutions, particularly new apps. And it runs every summer. And one of the critical propositions behind the Frontier Development Lab is that we are working towards something like called the Mission Control Earth, so that we use the most sophisticated computational tools like the artificial intelligence workflows to automate the tasks of basically gathering and combining all this data from all the different satellites and producing a strategic overview of what's actually going on and where are the crisis points and what kind of response can we deploy in those crisis points. And interesting enough, that's also an ambition that we have here in Edinburgh, because in Edinburgh, we'd like to become the space data capital of Europe. And we're working with partners like the Frontier Development Lab, as well as many others, to develop sort of different programs in support of that aim. So this is all part of something called the Data-Driven Innovation Program, which is an investment under the Edinburgh City Region deal. So Edinburgh and Southeast of Scotland City Region deal, which, I mean, to be fair, it's a very small part of the City Region deal. Most of the City Region deal is investments in roads and other sort of infrastructure to improve sort of the economic development of Edinburgh City Region. But there's a little bit of Edinburgh City Region deal, which is almost unique in comparison to other City Region deals, which is investing in the future of digital technologies that are going to help our city region and wider Scotland, and of course wider UK and the world in tackling the most difficult challenges that we're facing in the 21st century. I talked a lot about climate, but there's also other things like migration. Right now, we're in the middle of a global pandemic. So all sorts of things like that are kind of becoming more prevalent. We are hoping that this program is going to enable Edinburgh to be one of the centers in the world where digital technology can be deployed to try and look for solutions for these problems. And within the Data-Driven Innovation Program, we have a subsection called the Space and Satellite Innovation Program, of which I'm a part of. If you want to know more about it, that link over there, so just Google edinburgh.earth, you should find a page that sort of is more like a holding page. There's not that much there. But if you look at a place called Base Center, which is the top building in the corner there, so Base Center, and then look for Base Center, Space and Satellite, you'll find a little bit more details about what we're actually planning to do. So Base Center is kind of a big sort of building that's been built right at the University of Edinburgh, where a lot of the innovation around big data is being developed. And also, I mentioned Royal Observatory previously, and I'm sitting at the Royal Observatory. In fact, in the Higgs Center for Innovation, that's the bottom big picture over there. The lower, slightly newer and slightly pinker building just above those beautiful shrubs is the Higgs Center for Innovation, where again, we have a business incubator. So we're trying to support the development of a couple of businesses, as well as an innovation facility. So having labs and research spaces. And we also have some PhD students working there alongside established researchers and these new companies to develop new solutions for data analysis. And a lot of that actually is space data analysis. So whilst Higgs Center for Innovation is much broader, it also covers particle physics and some of the other sort of big science technologies of the past 20 years, actually space is a particular focus, and it hosts European Space Agency's business incubator for northern UK as well. Right. So in terms of the data-driven innovation program, this is something that I hold the HAL 9000 of DDI, on data-driven innovation. But it's a big circle that explains what it's all about. Effectively, there's 10 target sectors where our big data solutions are supposed to apply, and one of those 10 target sectors is space and satellite. So we're one of the 10. And in fact, if you look down into the fine print of the data-driven innovation program, you'd realize that actually space is the most important. It's one of the 3 anchor sectors for the whole of the DDI program. These are some of the targets that we're supposed to meet. We are supposed to meet over 1,000 students taught per year on our postgraduate courses, and over 1,000 people in our outreach engagements. So we'll try and do a count of how many people watch this video and add you all to our engagement targets, because we are trying to really cover quite a lot of ground here. But more importantly, this is a really significant investment. So we are hoping that there'll be over 60 million, well, in total, over 60 million pounds of research income focused on these sort of big data solutions for space and satellite. And then we want to have loads of new companies that are using our data and ideas coming out from the university, as well as actually getting data sets, existing data sets or new data sets established within the university for use by researchers and external partners, so maybe some of the developers as well. In fact, we've been talking about trying to work out with the Dundee Satellite Receiving Station how some of that archive can also be handled by the university in order to provide it for further analysis by researchers as well as some entrepreneurs. I won't even go into the details of how many companies we want to launch and all of this sort of stuff. But the scale of the ambition, the reason I put this up is the scale of the ambition. Edinburgh is hoping to become space data capital of Europe, and we have targets to match in that arena. And hopefully we'll also get some funding to actually get us off the ground in the same vein. And we have a particular reason to be ambitious and a particular reason to be confident that we can do this, because we've done lots of the analysis. There's actually a couple of sort of strategy reports that we've written over the past few years. They're looking at basically what's happening in Scotland and where does the University of Edinburgh fit in that Scottish story. And the thing, if you can remember earlier, I was sort of showing you the kind of, there's the manufacturing, there's the launch, there's the data downlink, and then there's the data analysis. Now this wheel is sort of going the other way around. So if you look at it you basically see that instead of going in sort of counterclockwise, this one's going clockwise. And you can start with the satellite payloads like we had before, and mission concepts, which are kind of in the bottom left corner, and then rocket systems, launch operations, downlink, data downlink, and then critically and somewhat unique Edinburgh capability, refining that data, having the processing capacity to actually analyze, refine that data, and then also analyze that data with our external partners, some commercial and some other universities and researchers. So in terms of the actually sifting through the space data and analyzing that data to produce new solutions, new actual insights that can be then employed in the real world, that is really where we believe the university has significant strength and a lot of things that it can actually provide. This is just one little proposal from that, and this is actually a part of a proposal we've been trying to develop. It's still kind of going ahead, but there's COVID and there's other pressures on the government. This was actually with the Department for International Development, which we're not entirely sure how long it's going to survive, but there we go. That's one of the reasons why it is taking so long to actually get things off the ground. We are working on a system that would effectively create a mission control for hotspot identification in Africa for potential sort of natural disasters and societal troubles in Africa. And the idea is to bring together the data from satellites and also potentially some of the ground-based sensors, using, as I said earlier, the artificial intelligence to process and analyze the stuff, and then using our scientific insights, the models that we've developed, both for natural environment as well as the way human behavior works, to then come up with these sort of hotspots identification and mapping. So we can actually provide like a traffic light system of saying like, this is a problem and this is how big we think a problem this is. And the idea, of course, here is that, if you think about that sustainable development story, we want to be proactive. We don't want to just react to things. I mean, so far, a lot of this policy in climate change, a lot of the policy in environmental protection has all been very reactive. We've realized we're melting the Arctic, and now we're doing something about it. But the idea here is that actually, if you really try and use these sort of big data solutions and as much space intelligence as possible, then actually you can build models that are somewhat forecasting. I mean, here we can't really say we can predict the future. That's a very dangerous thing to say, but we can spot patterns and trends that can give us pause for thought and pause for concern. And if you're a policymaker on international level, this is something that you might well be interested in particular, and that's the bit that is kind of in that sort of fake little laptop screen in the corner, in particular, if it is easy to use and easily accessible. A lot of the solutions, in the space industry, I mean, we have really quite advanced sensing and really very sophisticated models, but a lot of the solutions are only really accessible to Western scientists and Western states. And the reason for that sometimes is very practical, because in loads of places in Africa, you don't have enough bandwidth to download high-resolution images from space. You just can't do it, or rather, it takes you a week. And when you need rapid response imagery that is updated every couple of hours, then that's just not going to work, is it? So effectively, we need to think as to what kind of solutions we can bring to the sustainable development table that are not only state-of-the-art in terms of the insight, but also state-of-the-art in terms of being accessible and deliverable around the world. And here, Scotland is, again, one of the greatest places on Earth to try and develop these things. And in fact, I like to consider Scotland as a bit of a what we call living laboratory. There's a lot of theory about it. It's effectively a place where you can test out new innovation by engaging a wide variety of stakeholders. So we have researchers and research organizations who are producing the basic and applied knowledge, but then you also have companies who are taking those and developing various kinds of applications on the ground. You have regulators like Scottish government, local authorities, who can then look through things and say, well, we believe that, we accept certain parameters, we don't accept others. How do we regulate some of the, potential uncertainty in all these models, etc. And then finally, you have loads of people out there who are highly educated with quite a lot of technology already lying around, and they can use these solutions and they can sort of, be sort of not the guinea pigs, because it's not like that, we're testing something nasty, whether it will work or not, but to be partners in that development process to validate what does work in terms of communicating what's happening to our natural environment from space data, but to apply to an everyday situation. So this is a very interesting. So there's a little sort of tick box exercise really about these living labs, right? So we have Scotland is fantastic. We have the sea, we have mountains, we have loads of arable land that you can sort of monitor for things like crops and various sort of land use. We have lots of forests that you can use for monitoring logging. That's particularly useful because a lot of the development world is suffering from illegal deforestation. So that's effectively illegal logging. Being able to monitor that and being able to tell that something's going on is really, really important, but very difficult to do, because you kind of, in order to be able to, for your satellite to reliably spot an illegal logging site, you need to be able to test that somewhere where that logging is happening. So you can use legal logging in places like Scotland to actually calibrate your satellites to make sure that what your data is doing is actually valid, and that you're not dispatching forest rangers or people, police or whoever to the wrong place. And as also mentioned, we have the research capabilities, we have the physical and digital infrastructure that enables us to actually validate or ground truth, as we say, space data. And we have, and this is the best of it all, Scotland is small, but that's a big advantage actually, because it's a big advantage for two reasons. One, we all kind of know each other. So within the space industry, if you have a problem, you can always find somebody who's going to help you solve that problem. And often enough, you might be able to find somebody local. Because remember, I said earlier, we kind of closed the loop. In Scotland, our technological and scientific capability is strong enough that we can cover pretty much all aspects of space industry. And secondly, it's good because it is manageable in all these other ways as well. It is politically, economically, and geographically somewhat bounded together. So you can say that we've got similar circumstances across Scotland, and you can use that to your advantage, because you can kind of interact with various partners in different parts of the country in the same way, rather than having to, if you live in if you're trying to develop something in a big place like US, or even some of the other kind of countries in Europe, big countries in Europe, it actually is quite varied, and it's sometimes quite difficult to operate across state lines or similar sort of barriers. So Scotland is a great place to do things, and we also have lots of really exciting and really excitable people. People like Steve. I love Steve. Steve is a good friend of mine, but Steve has a really good motto, and it kind of epitomizes what space data industry is all about. His motto is that every problem on the surface of the Earth has a space solution. And the reason why I'm bringing up Steve is because, in order to make this slightly abstract discussion about all this sort of space data and space technologies more concrete, I'll give you an example that Steve and his team has actually developed. So a problem is something that if you live in Dundee, you kind of know about, because your coast is disappearing slowly. The North Sea, is actually got some quite relatively strong currents. If you lived in Aberdeen, you'd be even more aware of that, because a couple of years ago they realized that half of the beach is missing, and they had to put in special sort of barriers in to protect the sand from coastal erosion. But in any case, there is actually a legal requirement on local authorities. Particularly, there's this legal requirement is somewhat stronger in England, because they don't have. I mean, they have an environmental protection agency, but they don't have one as well developed as our Scottish Environmental Protection Agency is. So the legal requirement is actually on local authorities to monitor the coastlines for cases of coastal erosion. Now, the problem is there's miles and miles of coastline and not enough money to send people checking if their beach is disappearing or not in all locations all the time. So there's actually a standing conference on problems associated with the coastline, which is effectively a bunch of local authorities, a bunch of councils down in England, trying to work together to find new solutions for monitoring and protecting their coastline, particularly doing it on a budget. And working in particular with the New Forest District Council and somewhat supported by a Space for Smarter government program by the UK Space Agency, Steve's company, called Astrosat, has developed a solution for monitoring coastal erosion from space. Now, they are not using one of these small Scottish-built satellites. They're using SRR, so SAR, radar data from space. And effectively, the picture you see there on the right is a scan of a bit of the coastline, and you can detect. I mean, some of the white, slightly fuzzy bits right in the middle of the picture, those are just clouds. But you can see from the tip of that little peninsula, there is a plume of sand that's kind of swirling into the bay. That's effectively your sand being washed away from the beach because of the upwards current alongside that side of the coastline. So by doing so effectively, from space, you can spot that there is this sort of particular pressure point in and around that peninsula tip where the sand is being flushed away. And of course, then you still need to have your inspectors go there and monitor what's happening and propose potential remediation. But you don't have to go and control the whole of the coastline. You can use the satellite data to pinpoint where the big issues are and send your intervention in a more targeted way. And that's kind of the principle behind a lot of the space data. Space data isn't at the level of resolution where every single tiny building can benefit from the insights. It is more about pinpointing where the problems are and then sending in targeted interventions to support local solutions. I mentioned Astrosat, but in fact, there's loads and loads of companies working on this and similar problems all around Scotland. Here is just a list of a couple. Do you see? Most of them are in Edinburgh. This is because sort of space data analytics is really where you're starting to meet external clients, where you're starting to make money, and Edinburgh always takes all the money. So there's no worry that everything where the money is made is all hosted in Edinburgh. So we're quite proud of the fact that we have most of the space companies in Scotland actually all based in and around Edinburgh. But it's not quite the case. There's quite a few people also working on this sort of things in Glasgow. There's even there's people outside of the Central Belt as well. So it's not, Edinburgh is not hogging everything. But you can see there just a list of companies all working on various solutions. We have particular strengths in forestry. In fact, I mentioned deforestation previously. Companies like GSI, LTS, Ecometrica, Carbomap, as well as Space Intelligence, they're all forestry specialists. So they're all about finding out more about the way forests are growing or not growing, or indeed being cut down. So there's quite a lot of different approaches to that, as well as other sort of, say, agricultural parameters, and other sort of environmental issues and challenges. Now, finally, and I'm aware that it's already been kind of about 45 minutes, and I should probably start wrapping up. You might be wondering, so we have all these sort of companies, there's all this data coming down from space, and there's also sort of this analysis that is supposedly preparing solutions, which are effectively potentially disrupting way of life, or developing policies which are, obviously picking certain winners, and perhaps there's certain industries, particularly polluting industries, which, the space data will say, well, you need to just chop this off. So how is that actually all governed? Now, this is again a different talk, but I thought that it's quite important to sort of pinpoint that and really acknowledge it up front, and maybe we'll have some time to discuss this in the Q&A, because one of the critical questions really is, how are these algorithms, space data algorithms, actually disrupting and changing ethical systems that govern the importance and availability of ecological perspective? So yes, we have the overarching agreement with the Sustainable Development Goals, but what is the ethics and the politics behind it all? And as it happens, in Edinburgh, we also have a world-leading network trying to develop research programs around that. So not to just say space data is great, we just need more and more space data, but also what are the ethical considerations around space data, and how do we make sure that when we are doing sustainable development, that sustainable development isn't again on the backs of certain people and the inequality gets perpetuated. Rather, how do we really make sure that space data and other solutions coming out from this sort of big science research is in line with what with what is potentially right and good for many or most communities and environments. By the way, we also sometimes do crazy things. So the reason I put the Scotland in Space up there is if anybody's interested in space fiction, we've recently published a book which is about discourse about Scotland in space. And we've commissioned a couple of short stories and some interesting sort of natural and social science responses to those short stories. So if anybody is keen, a lovely group called Shoreline of Infinity have published this book for us, and it's all available now. So just in case if you're looking for a Christmas present for a space nerd. And just to kind of wrap it all up, so what is this all leading to in terms of my own personal research, and also as I mentioned, how this ethical questions actually ground, where are they going, and why do I have Transplantary Ecology in the title of this talk, and haven't we talked about Transplantary Ecology much? But effectively what Transplantary Ecology means, I mean, of course there's the trans bit, which is with reference to other places like Mars and Moon and things beyond, but the planetary bit, the planetary ecology, the realization of the fact that space data is, for the first time perhaps in human history, providing a very specific, unifying ecological parameter. It's maybe just 1 or 2 or 3 data points, maybe it is the 4 or 5 Sustainable Development Goals indicators that I showed you earlier, but it's effectively a global view on the way the Earth is actually working. And this is not entirely new, but the tools that we use today and the availability of more and more data that we have today is really what's making this quite a special time for space exploration, as well as space industry, which is of course where all this space data is coming from. And so if the 80s and 90s were all about going out there and building space stations and going further afield, and even now there's all this sort of talk about going out to Mars, etc. Actually, perhaps the most interesting part of outer space technology is now going to be the bit looking back down on Earth, because the impacts of that will be felt right around the world and for decades to come. That's me. Thank you very much.
Oh, sorry, apologies there. I lost my cursor momentarily. Thank you very much, Matjaz.
Matjaz, that was absolutely super. Thank you so much. I certainly had no idea how extensive this work had become. Some years back, I remember being impressed to discover that the Dundee Satellite Station had joint work in marine projects with, I think, Southampton at the time.
Yep.
And that seemed to me to be incredibly innovative, but life has moved on considerably since then in the intervening time. Have we questions coming in, David?
There's not actually questions, but there are comments on the satellite receiving station, which has some input to myself, because a spin-off company from Dundee University. As somebody noted, the satellite receiving station was defunded by the university.
Yeah.
And
well, it was defunded by NERC, wasn't it? Unfortunately.
Yeah,
I think that was the problem behind it.
The university could have taken on the funding because it wasn't really much. So the guys who worked there managed to get the funding, and they've now moved it to Errol Airfield, which is a small airfield just outside Dundee. It's actually just about 2 miles from my house. And they've managed to set up, bought the dishes and the processing systems and all the recorders. And they've now got one of the dishes up and running. So they're back online again, and should be supplying, hopefully very soon, commercially supplying data to you and to other companies around the place. So at least that's one good thing that's come out of that.
I think, and I think there's an additional reason why that is such a good news. And unfortunately I wasn't really paying enough attention to know exactly the details, but I know there was a crowdfunder set up, and there's quite a bit of investment. So, you know, I think, and I've been saying this actually publicly for a while, that the situation with the Dundee satellite receiving station, rather the lack of support, like the lack of recognition of its strategic importance, is quite tragic. Because this is, I mean, you remember my wheel of everything, right? The wheel of everything doesn't work if there's anything missing in it, and without that expertise, there actually is a missing bit within about data downlink. And the reason why I say that is because on one hand, I mean, you have some companies in Scotland who do data downlink as well, and who are building dishes, etc., but are doing it effectively as needs basis, right? So, you know, there's particularly a company called Spire, for instance, in Glasgow. They have a fleet of their own satellites, and they have a cluster of their own satellite dishes actually dotted around the world. But they're doing it for their satellites, and they're not really pushing the envelope of what satellite data receiving can do, and how data is processed, stored, analyzed, all of those other additional things, which are actually important if we are to remain competitive. And I think it would be absolutely tragic if Scotland lost that key capability. And I'm delighted. I did not know the last bit of that story. Perhaps all the pandemic and everything kind of got in the way of me actually paying attention to everything that's happening. But I'm delighted that this is now continuing, and I'd love to visit one day. I know the airfield actually very well, so I'd love to come around and have a look, because I think it's critically important that story continues, and that expertise is not lost.
Yeah. Oh, definitely. I mean, there was even comments from NASA saying how vital the satellite receiving station was, but the university seemed to be focusing in other areas rather than, in fact, it was a moneymaker for the university, even without the NERC funding.
Right.
It was bringing in a lot of money from just selling the data. But,
yeah, universities are not always best places to do technology development and to do to have a kind of a strategic vision. That's why, I mean, we are very privileged right now in Edinburgh with the Datadriven Innovation program. And since we're being recorded, I shouldn't probably say this, but I will say it nonetheless, that even though we are really privileged because there has been this significant investment in our capabilities, to be entirely honest, we've written 2 strategic reports that are calling for a particular way of doing things. And the funding isn't there yet. And it is not clear that it will ever be there to actually capitalize on our equally important role in being able to provide these world-class analytic facilities and expertise. So unfortunately, universities, you know, even when they're basically given a mandate to do something, they still not necessarily do everything. I've had a quick chat with a very good colleague of mine today, and we had a little giggle about death by a committee, right? anything you want to do within an organization the size of a university that's been around for as long as most of our universities have been around needs to be approved by at least 3 committees. And you bet there'll be somebody, at least 1 or 2 of them, they're going to have a serious objection, and then everything gets basically just stalled.
One of the things I was going to ask is that, I understand that you're the principle of you trying to get ethical systems into place with this work, but it seems that the work requires multi-agency involvement, and how you keep control of that and the direction of travel that you would like to see, and how you manage to steer through so many agencies. That has to be hard.
Yes. Well, again, this is the nice bit about being at the university. We are academics, right? So we can call upon people to say, like, what do you think? And not to say that we didn't operate in a vacuum, but you can kind of develop strategies in which you collect bits and bobs and make something out of it. Because you're right, it is very difficult to kind of keep on engaging multi-level on multi-levels and multiple stakeholders or multiple sort of involved actors, and so that is very, very hard. In many ways, it's also not necessarily universities' mission. I mean, it would be a little bit. I mean, we're not meant to regulate. We're not meant to. We're not even necessarily meant to be the spearheading the development. We are, as I say, in a relatively unique position that we've been given a particular mandate through the Datadriven Innovation program, and we are relishing that mandate, and we think it's important. Because one of the things that I've been observing in my research in the space industry Scotland, if anybody was paying attention, there's quite a few references to my papers actually. What I said, I didn't talk about them, but what I said actually is based on actually spending the past 10 years almost, in and around Scottish space industry. So there's one of the things that's been lacking so far actually in Scotland a bit, is that a lot of the hyped up new space companies haven't actually been backed up by advanced research. They are actually going after a lot of the stuff that's sort of effectively low-hanging fruit. That's why things like Dundee Satellite Receiving Station is so important, because that has been backed up by research, that has been, properly developed within the electronics and engineering research. So in similar ways, there's for stuff in terms of satellite development, a lot of that is sort of playing catch up. Strathclyde University, they're doing very good work, very, very good work. But a lot of that is somewhat reactive to what's happening. So again, universities are kind of in a really strange position here, because we take on quite a lot, even things that maybe we shouldn't have. And the problem right now is, for instance, that we have the UK Space Agency, who is notionally sort of steering development, and also at the same time the main regulatory body for the UK space. But again, I mean, they have particular pet projects and obsessions, and even big agencies like NASA and European Space Agency are sometimes struggling to really create a very kind of collegiate environment, and to make sure that all of these different stakeholders are kind of well aligned. So I think the call here is that everybody can do their own little bit, and in the end we can only worry about what we can influence, and we engage with everyone who wants to engage with us, but we can't force anyone. We can't manage everyone.
Right, I got a question coming in on the chat. What you've talked about up to now has been on terrestrial image sensing and processing, but do you see yourself or any other people in Scotland getting involved in things like exoplanet survey, data processing, things like the Aerial project, the atmospheric remote sensing infrared exoplanet large survey? Is there any chance that we'll be doing some work in these areas?
We are doing that. In fact, Ariel, there's some scientists who work on Ariel who are based at the Observatory. So I think they're mainly in the technology side of things, but yes, Ariel is very much on the radar. We are involved in all major space missions, from, of course, James Webb Space Telescope, very famously right now, of which there is also exoplanet science that's part of the science case for it. There's Gaia, sort of dark matter mapping, you name it, it's there. I mean, of course, excellent work in Glasgow on LISA Pathfinder and gravitational, so space gravitational wave detection. So I think I've almost taken that as a given. Maybe I should have mentioned that. I mean, I've really focused on all everything that's happening looking down. But there is probably right now, in terms of expertise, there is more expertise in Scotland for astronomy and space astronomy than there is for sort of geosciences and space science. In fact, as I say, a lot of that is centered on Edinburgh in our School of Geosciences. Whereas in terms of astronomy and looking outwards, actually, we have several leading research centers, world-leading research centers in St Andrews, in Dundee, in Edinburgh, Glasgow. So there's, you name it, it's there.
Yeah. Oh yeah. That's I think Scotland definitely, as they say, punches above our weight in terms of both satellite technology and in space science and in general and astronomy. So yeah, I think we're doing pretty well.
Absolutely.
Yeah. There's no other questions on the chat at the moment, but I think everybody's very impressed by the talk and certainly got a lot of useful information out of it and learned a lot about what's going on in the space and technology world.
Absolutely. That is really, really good. To get that overview of what is happening in what is such a diverse field is really good. Thank you very much for that. Do you have priorities of work that your particular team are focused on?
It's difficult. It's complex and quite difficult to explain. So right now we actually, I'm called, what it's somewhat lovingly called early career researcher, which basically means that you don't really have that much money and you have no control over what you do. You just try to kind of align things along. But actually, I did manage to do a couple of interesting things. So we've been working. I've been working personally on several things. At Edinburgh, I'm actually working right now in the School of Engineering, and we're trying to develop our programs with our students actually to dip our toes into some of this hardware engineering. So I personally supervise a couple of master students who are actually looking at various sort of engineering solutions for small rockets, for space stations, for satellites, small satellite platforms, all sorts of things like that. And we have other colleagues who are working in similar direction. And remember that last bit was about sort of ethics and data and how do we actually reach out to the rest of the world. I'm really excited that actually one of the projects we're currently working at the moment is with a big sort of external partner, a big science festival. And we are looking at how perhaps we can use some of the climate data, maybe, hopefully, as much as possible, satellite space data to contextualize what the climate change is actually, what the climate emergency actually means on the local scale. Because to be fair, here in Scotland, we obviously are very much aware of the climate emergency. We have some of the really world-leading policies in terms of energy efficiency and net zero carbon and things like that. But in many ways, it doesn't really impact our daily lives as it does in other places. I mentioned some of the places in Africa in particular where flooding, droughts, all sorts of things are really significantly impacting their daily lives. So we are thinking actually of creative ways in which we can contextualize global data on a local level to make that emergency of it apparent. And it's quite interesting because we're trying to use some of the same tools that we use to analyze the data to also then effectively not de-analyze the data, but to kind of translate the data into something that is more relatable. So we're using artificial intelligence and sort of ways in which we can actually personalize experiences of this global digital data. So loads of projects in various directions and too few hours in a day to actually keep on top of it all.
You pointed to the kind of slightly pink building, saying this relatively new building. Are the resources and staff and grants coming in? Is this an expanding area now?
This is definitely an expanding area, not just in Edinburgh, around the world. I mean, the space industry, what's really happening in space data industry is it's a kind of configuration. I have a slide actually that I didn't show because I was kind of scared of the amount of time we have. Why is there so much? Why is this big explosion in space data? Well, there's kind of three things really. On one hand, there's a lot more open access data. Open access data from space was kind of always there. Like I mentioned, the satellite receiving station taking off imagery from American meteorological satellites. This has been going on for tens and tens of years. It's not new. But there have been new programs like the Sentinel program from the European Union-funded European Space Agency launched group of Earth observation satellites, where really the data has magnified tenfold, hundredfold. And also access to it has expanded. Because back in the day, you really needed to have your own satellite receiving station to get the data down. In fact, even the Met Office didn't really have one, so they've contracted Dundee satellite receiving station to send the meteorological satellite imagery from Dundee down to Portsmouth. So, you really had to have that infrastructure, whereas nowadays, you don't have to have that infrastructure. You can just Google Copernicus, go onto the program website, and there's these data centers all around Europe that you can just download the images from. Now, of course, you need to know what you're doing, and that's not trivial. You need to be able to, as I mentioned previously, issues with bandwidth. You need to have bandwidth capable enough to download high-resolution images, which is also perhaps more trivial here in Scotland, but if you're somewhere in the middle of Africa, not trivial at all. So there's lots of sort of hurdles, if you like. But there's a big explosion of that. That's one bit. Second bit, processing power has increased exponentially. 10, 15 years ago, only a university with a big research computer, a big corporation with a kind of a really capable sort of multi-core computer could process high-resolution images to the level that there's useful insights for applications on a global scale. Today, Amazon servers can be contracted out for a couple of pence for kilobyte or whatever. I don't really know exactly what the going rate is, but very, very cheap. Yeah. Processing power in similar way you can kind of contract out. So even a small company or even like an individual can go and download stuff, process stuff in a way that wasn't possible before. And this is cloud computing, completely changed the game. And then yes, there are also the small satellites. And the small satellites, perhaps not so much, and I know this is really annoying for astronomers and being, I do a lot of the dark sky discovery stuff. I do community development in the north of Scotland around dark skies. And so I'm the first person to say that, satellites with high albedo are just the worst nightmare that you can possibly have. But on the other hand, satellite constellations, so the ability to put these small satellites in trains that go around the world and are scanning surface, because you can put them in trains, because you can put them in constellations, so you stack them one after another, you get high revisit rate. So you don't only get an image of, let's say, the UK or Scotland or Dundee, once every week, like you had with some of the big satellites further afield. You can get it every hour, and you can detect change in near real time. And that is completely changing what you can actually do and how critical this infrastructure can become. So it's not only this sort of pan global view and this kind of general policy making of, let's say, well, yeah, the Antarctic ice and the Arctic ice is melting, so we should do something about it in the next 10 years. It is also, we're having a big fire right around the corner, send the fire brigade. And there's nobody that, this is particularly for instance, again, in Scotland, because of various geographical parameters are not maybe that relevant, but like let's say in US, they are having, you can have early warning for wildfires in a way that you couldn't have before, because there's obviously nobody there in the middle of nature reserves, etc. But you can spot this from satellites because they can detect change in a matter of a couple of hours, and so you can intervene a lot sooner before there is an uncontrollable wildfire, when actually dispatching a couple of planes can deal with the thing.
Yeah, that's good. There was something else that came in. Probably more relevant to something you were saying just a few moments ago, is about citizen science and people at home doing work. Do you have any plans for farming out any of your ongoing research to citizen science projects?
So I don't actually do. I mean, I help steer satellite space data development. I don't actually do any of it myself. I'm the typical ivory tower academic. I know best, but I can't really do anything. No, but I mean, there's been astronomy has used this to extreme advantage. We know Planet Hunters, Galaxy Zoo, etc. Actually started off, citizen side really in many ways started off with these big projects in astronomy. To be fair, space isn't yet at the same level. I think with space, I think the interesting opportunity maybe isn't let's say, in data analysis, like it was in astronomy. I think the interesting opportunity in space is ground truthing. So using our other devices like mobile phones, or, we have this sort of Internet of Things. So effectively, your fridge now connects to the World Wide Web. So can a little sensor in your garden that's measuring soil moisture, right? And so particularly in this sort of living lab context, when I said, like, we can use Scotland as a test bed, and we can use sort of, we use satellite imagery, we scan the surface, but then we have people on the ground who can actually verify what's going on. In this sort of sense, I think there's huge opportunity for citizen science, where actually you can place, various kinds of sensors, detectors, or indeed use people's reporting tools through apps or other digital technologies to actually capture what's really happening on the ground and compare that to satellite imagery, and vice versa. Send information from these new systems to people and see how and how they will react, and how what sort of things they can do in their local environment. And in fact, again, world leaders in this. In fact, the University of Dundee was leading on something called the GROW Observatory, which is one of a series of projects funded by the European Union called the Citizen Observatories. And these are effectively really projects like that. It's about citizen crowd-sourced data. Sorry, not crowd-funded, but crowd-sourced data. So you have a community of people who are all contributing information in a particular system, and then there's ways in which that can be sort of analyzed and then used for various things. And GROW Observatory actually has been looking particularly at agricultural data, or other soil moisture data in parks and gardens and things like that, and mapping that against other data sets, including space data. So I think that's a really, really significant opportunity for citizen science. In fact, one of the recent, I write these reports one per week almost, but we've recently actually developed a whole framework we could use called Citizen Data Exchange, which wouldn't only be about actually citizen contributing data into all these sort of research projects, but actually the citizens themselves also, data is money. Data is actually valuable. And I think there's a problem right now that we have, which is that we don't really necessarily value our data well, or rather, there are people who value our data well. Google is making a lot of money of all of us, and our behavior on the internet. It's just that money doesn't really come down to us. It all goes to Google. And so we were actually looking at ways in which we can make sure that there's an exchange, that citizen scientists, sure, you do it voluntarily and you do it because you're interested in something and you care about something, but you exchange your data for insight or for tools that otherwise wouldn't be available, that you can then stretch the impact that data has in your local community, and that can go further. So we are actually looking at a whole host of possible ways in which we can not only do citizen science, but go one step further and have digital citizenship, where we can really kind of make sure that it's not just something to the benefit of science, but is actually really making an impact on the ground and in our communities.
That's great. Thank you very much for that. There's no other questions on the chat at the moment, but quite a few comments on how excellent your talk was and how much people have enjoyed it. So I'll just pass on those thanks and congratulations.
Absolutely, that really was superb. I will try and look more kindly at trains of satellites, but it could be difficult,
Sure. They have to paint them black, right? There's now already kind of quite a bit of engagement around that, and particularly people like SpaceX have realized that actually annoying all of the astronomy community is not a good idea. It's not a good idea. So they are already now in discussion with various people who can advise on technology development to make them least disruptive as possible. Maybe Starlinks are not the worst, but unfortunately, it's not. The question is really, they're probably not the worst we've seen yet, because I think there's other actors who might be less courteous to astronomy community, and so of course
that might be the problem. There
is a big potential for problems there. More broadly, if anybody has any questions later on, you can find me online, drop me an email, or I'd be delighted to talk to anyone and everyone. And if you have any questions, just fire over. There might be some delay in replying. I am going on a long-deserved short break next week, but I'll try and get back to you as quickly as possible.
Matjaz, that is very generous of you. It really is. And thank you very, very much for your time. That has been a hugely interesting talk. And I am delighted that you managed along this evening to speak to us. And hopefully we will see you at some point in the future again. That would be just great. But for now,
I'm counting the next time I see you, it will be at the Mills Observatory.
Yeah.
Oh, fingers crossed, absolutely. So we would be delighted to welcome you to the Mills Observatory for all sorts of reasons. That would be just terrific. But in the meantime, thank you very, very much for coming along and giving your time to us. Excellent.
You're more than welcome, and I hope you all have a nice weekend. Clear skies. I really wish clear skies, but the weather forecast is not good. So,
it's not looking good again. Actually, it's definitely awful.
Yeah, whenever clear skies come around again, I wish you lots of good observing.
Thank you so much, and all the best to you and your work.
Cheers.
Thank you. Now, thank you.
Right. All right. Let's switch off the stream. I think if everybody's got all their questions in,
Okay, thanks to everybody for joining in tonight. We'll see you again soon.